Hello and welcome to this webcast on Geographic Calculator. I'm Taya Youngs, an applications specialist for Blue Marble Geographics, and I'm here with Sam Knight, the Director of Product Management.
Hello, this session is going to be on getting started with Geographic Calculator. Today's topics are mainly going to be an introduction geared towards the new user. No previous experience with the application is going to be required to understand what we're doing. We're starting right at the beginning. The interfaces we're going to be taking a quick look at are going to start off with the project manager. We're going to focus mainly on the interactive conversions job for getting around the basic infrastructure of setting up a conversion, and we're also going to take a quick look at some of the data source dialogues.
You can subscribe to these videos from our webinars page at www.bluemarblegeo.com or from our YouTube channel page. Additionally, you can find out about training opportunities at our training site. You can see both web addresses on the screen right there.
And as always, if you have questions about anything you see in these sessions or to follow up with suggestions for topics in the future, you can send those suggestions or questions into geohelp@bluemarblegeo.com.
So let's start with the basics. What does Geographic Calculator do?
Geographic Calculator is an all-in-one geomatics data conversion solution. So it does things like converts coordinates between coordinate systems, performs coordinate transformations between datums and other types of coordinate systems. It handles things like local survey grid conversions over to something that's geodetically based. And it does this on a variety of geospatial formats, everything from simple points that are numeric data, one coordinate at a time, to databases of points, vector files, and raster files. All told, it supports about 60 different formats of data.
So where do we start?
Well, the Geographic Calculator is laid out in a project-style workflow. So over on the left-hand side of the interface, we see the project manager. And in the project manager, right out of the box, you'll see 5 basic types of jobs, and these are just the most common types of jobs that you'll find in the calculator for your typical everyday kind of workflow. And there are a few other types of jobs that are a little bit more specialty that we don't include listed there, but can be added to your workflow at any time. What we're going to be introducing here in this session is going to be stepping through the basics, mainly of an interactive conversion. That's the interface we see here on the right. And we're going to pass through some of the other jobs as we get a little bit farther on into this session. We're going to be talking about things like point database conversions, where we load in spreadsheets and tables of numeric data, seismic survey conversions, where we deal with some specialty seismic data formats, things like SEG P1, UCOA P190, the current OGP seismic formats, vector data conversions, where we handle things like shapefile data, AutoCAD, MapInfo formats, your basic vector data types, and raster transformations, where we handle everything from GeoTIFFs to ECWs, JPEG 2000s, Mr. SIDS, and so on, with georeferencing and reprojection capabilities. So we're actually going to start out here on the interactive conversions job. This is the simplest place to work in the Geographic Calculator, and what it does is handles conversions and transformations from one single numeric coordinate to another single numeric coordinate. So we're only talking about one position, and the only complexity here is the formatting of the data. We're going to use this as an example of setting up any type of transformation throughout the application, because really the process is similar in terms of working with all of the standard dialogues for selecting your coordinate systems, choosing any formatting options if there are any necessary, picking coordinate transformations between those systems, and then completing the conversion. Where things get more complicated with additional data is in the data itself. Things like the point database conversions job, we're talking about rows and columns of data. In the seismic survey formats, we're talking about very complex structures of tabular data. Vector data conversions is fairly simple, but it is there are specific settings dealing with multiple layers and so on. And each type of data that we have has its own little nuances. We're going to focus to begin here on just the core of setting up a conversion or a transformation itself. And so to do that, we have these standard coordinate system controls on each job. you'll see two coordinate systems, one on the left and one on the right. And typically the left is going to be the input system and the right is going to be the output system. On the interactive conversions job here, you can actually toggle which direction is input and output on there. So you'll see I can click my directional arrows at the bottom, and my input and output systems flip around so that my input system is now on the right-hand side and my output system is on the left. That's sometimes useful if you're going to be doing a series of conversions. For getting started here, I'm going to refer to the left-hand side as my input and my right-hand side as the output. So on the coordinate system controls, each one of these has the system name, and that's going to be either a very simple name, as we see here for our NAD27 system, and some of those names might be a lot longer as we mix in particular coordinate system zones from different parts of the world, different date epochs that go along with those. Each of those is going to have a horizontal system as well. So the horizontal system is typically going to be the base datum in that system. And then we also have epoch dates for those. We have the type of units that are going to be used in the system. And we also have an optional selection of a vertical coordinate system.
Why are the dates shown?
So the dates on the coordinate systems are used for particular coordinate transformations that we refer to as a temporal or a time-sensitive transformation. So you can actually define for certain systems that are typically going to be our modern GPS-era systems, systems like WGS84, any of the ITRF systems, or in North America, the NAD83-based systems. Those actually allow you to define when your data existed so that they can model in things like continental drift into the transformation. That is a very particular group of coordinate systems. There's only about 25 of them in the database. But there are other things that the dates get used for as well, such as magnetic declination that you'll see the field for up at the top of this. So it's not just a matter always of where your data is, but also when your data is. So to begin with the selection of a coordinate system, you'll see I've already got a couple set here, but we're going to take a look at actually making that selection. So to change the coordinate system, we're going to double click on the system box. And it's going to prompt us whether or not we would like to limit the available coordinate systems by geographic area. This is a prompt that you can have pop up each time you launch your coordinate system picker, or you can set it to a particular default and it will then follow your setting therein after. The first time, we're going to take a look by narrowing this down based on geography. So I'm going to go ahead and say yes, let's narrow that down by geographic area. And what that does is it's going to open up a map control. And this map control allows us to define exactly where on the planet we happen to be working. So I'm just going to zoom into the area here of Maine on the map, and I'm going to simply click to define a marker on the map. And this marker is going to be used to narrow down the list of available coordinate systems to choose from. And we'll take a look at exactly how that affects the dialog here in just a second. So once we've added our point, we're going to go ahead and click OK down in the lower right-hand corner of that dialog. And then it's going to open up a filtered view of the database of coordinate systems in here. And it is specifically going to narrow down all of the available coordinate systems based on that point that we defined on the map control. So that map control is an optional setting. If you say no to that prompt of if you'd like to narrow them down based on geographic area, it will launch this same dialog that we're looking at right now, except it will actually show the entire database of coordinate systems from all over the world. So that's just one optional piece of help that you can get in order to narrow down some of those selections. Now the database itself contains about 5,000 coordinate systems. There's a little over 5,000 coordinate systems in the database, and they're all broken up based on geopolitical organization. So you'll see first we have different categories of coordinate systems. We have fitted engineering systems. Those are local survey grids that you actually define yourself. We have geocentric coordinate systems. also called Earth-centered, Earth-fixed coordinates, if you're familiar with those. Geodetic systems are all of our latitude and longitude based systems. Projected systems are our typical map projections, things such as transverse Mercator, Lambert conformal conic, simple cylindrical, and about 100 other different types of projections available that make up all of our common mapping systems. And lastly, string-based coordinates, and these are specialty systems that involve special formatting of the coordinates, and they could come from a projected base or a latitude-longitude base. Those are going to be things like the World GeoRef coordinate system, survey grids such as the Alberta Township system, and things like British National Grid or US National Grid, and so on, where you have non-numeric coordinate data with things like zone definitions as a part of the coordinates, and so on. Now, we narrowed down our view of the data source here based on geography. So if I take a look down under the geodetic category of systems, and I hit the special category here of all, this is going to show me all of the geodetic coordinate systems that are available around that point that I selected. And if we take a look at this list, we'll notice there are, just going to estimate here, there's probably about maybe 60 different coordinate systems available to us there. And these are all world coordinate systems. So you'll see all of the various IGS models, ITRF, and then there's a few North American models, our NAD27 and NAD83s and so on, that apply to large areas of North America. And then as well some definitions that actually have rather academic names of unknown datum name coordinate system, and so on. That list is going to be much, much shorter than it would be if we had not filtered that down based on the map. So what I'm going to do is cancel back out of here, and we're going to double click on that again to see the full view of the database. We're just going to double click on there, and this time we're going to say no, let's not filter that out based on geographic area, and we'll look at that same category. We're going to look at all under geodetic, and we'll see here now in this list we're looking at somewhere more than 500 coordinate systems that are found. And you'll see under area of use, we see areas from all over different regions of the planet, rather than just that little localized area that I had defined picking from the map. So in this coordinate system organization of being geopolitical, down under geodetic, if I'm looking for a latitude-longitude system of NAD27, which is a common North American coordinate system, I can look under the North America folder, and there's where I will see systems that are designed to cover large portions of the continent. And if I drill down a little bit farther, say under a particular country, such as the US, I'll see models that are local to that area.
Where do all of these coordinate systems come from?
Okay, so there's about 5,000 coordinate systems in the database. They come from a variety of sources, but the vast majority of these come from a database known as the EPSG database. That acronym stands for European Petroleum Survey Group, and that organization is actually it's a defunct name, and the database is maintained by a group that is still current called the International Association of Oil and Gas Producers, or commonly referred to as the IOGP. The EPSG database still maintains that acronym, and you'll notice assigned to many of the coordinate systems in the database, you'll see this column called EPSG code. Now, each coordinate system and each geodetic parameter, this isn't just limited to coordinate systems themselves, they each have these codes for items that are in the EPSG database. The database was originally created by sort of a common working group of geodetic folks from various oil and gas companies around the planet. All of the major operators were involved, and they were interested in forming a common database that could be shared between various companies and services companies and surveyors doing positioning work all over the globe to serve as a common standard that could be referred to. So all of the parameters that have an EPSG code are commonly available in the database. They're able to be looked up on the web. There is a free open portal at the web address EPSG-registry.org. And these can be looked up by name or by these unique codes. Most of the codes are actually unique in the EPSG database. They are the only codes that are not unique are actually they are unique to each type. So a particular EPSG code for a coordinate system would not be used for any other coordinate system, but it could be assigned to something like a linear unit. So they are unique in that way. Now, I mentioned that most of the coordinate systems come from the EPSG database. There are a few other coordinate systems around the world that are not from the EPSG database. So I'm just going to click into this folder called HTDP. That is a folder of time-based coordinate systems. The HTDP designation stands for Horizontal Time-Dependent Positioning. That's one of those types of systems that uses the time-based transformations I just mentioned a few minutes ago. And you'll notice that a number of systems in this folder are not EPSG-based systems, so they have no EPSG code. The EPSG database itself has really become sort of the de facto standard for publishing coordinate system parameters, but there are things that are not actually yet found in it. And those might either be new coordinate systems, or they might just simply be old definitions that are very, very rare or not commonly used. And for one reason or another, they simply have not been designated in the EPSG database yet. So with all those 5,000 coordinate systems, most of those have an EPSG code assigned to them, and they can be very easily looked up on the web. And the ones that don't, there's probably several hundred of those as well. And they're going to come from a variety of sources, whether that be a national survey authority for a particular country, or whether it come from a particular academic or commercial publication on a particular coordinate system or a particular datum model or any of the geodetic parameters.
Are custom coordinate systems supported?
Yeah, so the end user is free to add any number of customized parameters for coordinate systems or any of those same types of geodetic objects we've been talking about, such as horizontal datums or linear units or angular units or any of the individual parameters that are found in the database. You'll notice that you don't have the ability to modify any of the coordinate systems that we're looking at in this selection interface. You'll actually see this little padlock icon designator, meaning that these are all locked parameters. And the end user, if you open any of these up, you don't actually have the ability to modify any of these settings. If you want to use custom transformation parameters or coordinate systems, you actually need to start in a different menu. So you need to take a look under the data source menu, and you'll find an edit interface that allows you to climb in here and add any customized parameters that you want. And you'll actually notice that I have a couple of blue coordinate systems showing up right here in my list of projections. These are customized parameters that I've added to my own installation. The text will be lit up in a blue text, and you will notice a lack of a padlock icon next to those entities. You're also going to notice a couple of extra buttons at the bottom of this interface. Here we are in an edit interface that is distinct and found only under the data source menu, rather than the selection interface that you'll get when you double click on any of the blue boxes on the main interface. So to create a custom coordinate system, you simply come into the edit mode of the database and you click the little new object button. That's the addition sign at the bottom. And this is going to open up a editable version of the, in this case, it's a coordinate system editor, but you also have the same functions available for any of the geodetic parameters found in the database, from horizontal datums to linear units to full-on coordinate systems as we're looking at right here. That's getting a little bit farther down the road. So today we're basically going to be focusing on predefined coordinate systems. If you are interested in custom parameters, there are some more advanced webinar recordings that we have dealing with just that topic, and you can find those right on our YouTube channel. So I'm just going to close out of this edit tool, and I'm going to go back to our selection mode. that we were looking at the unfiltered view of the data source. So in this case, I'm going to say no to filter it down by geodetic area, and I'm going to come right back to my North America folder here, down under geodetic for a lat-long system. Now, the coordinate system that we already have chosen for us that was saved into my job when we started is NAD 27, so the North American datum of 1927. I'm going to find that, since it is a continent-wide system, I'm going to find that down under the North America folder, and I can open that up simply by right-clicking on it and selecting View Info. This is where we can go if we're not entirely sure if the parameters match the coordinate system that we need. So you can break this open and assess all of its defining characteristics. So for a latitude-longitude coordinate system that you're going to find here in the geodetic folder, it's a fairly simple definition. There's an area of use that defines exactly where on the planet this coordinate system is found, and that's actually what we use to help narrow down that list by the map, if you do use the map control. The point style is essentially the units that we're going to be using in the system. So in this case, it's defining that it is a geodetic point, or a latitude-longitude point, with degrees as the unit of measure, and then a horizontal datum to base that system on. So the datum giving us the size and shape of the geodetic model that we're working with. Now, the latitude-longitude system has the datum, and the datum name in this case matches identically to what that system is called. But any of these parameters can also be opened and take a look at the defining parameters of those parameters. So let's take a look at the datum here. I can click the information button next to the datum, and that's going to open up for me a dialog that defines the horizontal datum itself. On the definition of that, we can take a look at the ellipsoid that is used to define that datum, the prime meridian that's used, and if we wish, we can actually open up the information of that ellipsoid and so on, all the way down to the bottom of that definition. So there's not a single parameter here that is hidden to the end user when you're making these choices. So you can be fully confident that you are actually choosing the definition that you think you are. So I'm just going to back up a couple of steps here to the geodetic coordinate system. And we started out here looking at the definition tab, and as I opened some of those dialogues, you probably saw the identification tab popping open. Every definition in the database has both an identification panel and a definition panel. And as such, they are exactly what they say. The identification panel has various information about that system. It helps us identify that in various databases, and it gives a little bit of extra information about some of these coordinate systems or datums or whatever it is we're looking at. The definition panel is where it actually has the parameters that define that system, but the identification panel helps us match that up in other places. So things like the remarks field, some of those will have comments that typically come from the EPSG database, very often referencing the source of the information that those parameters are based on. And at the bottom of the panel, we have identifiers, and these are codes that can be used to reference a particular set of parameters into other databases. So you'll see codes in there from BMG, those are our own internal Blue Marble Geographics database codes. You'll see CS, and whenever you see a 2, 3, 4, and so on with the same prefix, those are multiple codes referencing the same entity in some other database. So CS is for the CS map open source library. EPSG codes are found in there as well. ER Mapper is an older software database that is found with ECW compression software and such. OGP URNs, those are actually addresses that can be used to query into the EPSG database online. PRJ codes are associated with Esri PRJ files, and in SRIDs, the last ones we've got here, and in this case, those are associated with Oracle Spatial Database formats. Now, each individual coordinate system could have any number of codes assigned to it. So the codes are really only for identification. If you don't see a particular code assigned to a coordinate system or any of the parameters, that really just means that it doesn't align with something in another database. If you are trying to match up database entries from system to system to make sure you're, say, replicating the same conversion in two places as a double check, you can use those codes when you see them to make that assumption that those two systems are in fact the same thing. We have validated every single one of these where you see multiple codes for them against whatever other database that happens to be. So after inspecting all of the parameters in the coordinate system that we're going to be selecting, you can go ahead and say OK to that. You can back right out of the identification or the definition panel, and you can simply double click on the system that you want to use, or you can select it and click the OK button. Either will select that coordinate system and return you back to the interface you're working on. So here we are back on the interactive conversions for single point conversions. And we've entered in a coordinate already. So in this case, 44 degrees north and 70 degrees west longitude. You'll see that I've used a minus sign to designate that I'm going west. You can just as easily either use a prefix or a suffix of the cardinal directions. So N or S for north or south, E or W for east or west. And that can actually be a prefix or a suffix, and you can insert a space or not. It's a very flexible interface, and it will recognize any of those designations, whether they're the letters or the signs for the hemispheres. Now, as well, we also need to designate the format of the data that we're entering in. Since this is numeric data, there are multiple ways that those coordinates can actually be written down. Now in this case, you'll see the display formatting is set to decimal degrees. So we have our whole degree values and then a base 10 fraction of those degrees. And in this case, I'm using nice solid numbers. But in the case where you do have fractional components of those, you'll notice the format button along with these coordinate system controls allows us to set the left and the right format for those. So from all of the different various common and uncommon ways to format decimal degrees, from things like decimal minutes or degrees minutes seconds, or some of the packed and truncated formats as well. So the format dialog sets for us the output display precision and whether or not we're using things like sign degrees or if we're using the various cardinal directions to designate what hemisphere we're in. So most of these are more important for the output settings. Basically, the format itself is needed for input, and we can recognize flexible input of decimal precision and those hemispheres. So everything from decimal precision on down is really more for your output settings. So mine are all set on decimal degrees, and I'll go ahead and accept those settings. Okay, so with our coordinate system selected for input with our NAD27 system and our format set as well, for this example we're just going to take this out to the default coordinate system of WGS84, but we could also do this to any other system. This is just going to be a common example that we use for demo here. To actually complete this transformation, because we are going between two different systems that are based on different horizontal datums, we are going to need to select a coordinate transformation in the center dialog box here in the middle. So we're going to double click on this box, and this is going to bring up for us a list of possible ways to complete the chain, to transform from the input system to the output system. So what we'll see is a categorized list on the left-hand panel here, much like we have our geopolitical organization for coordinate systems, except you're typically going to see a much shorter list there. And then in the details pane on the top right, you're actually going to see the individual transformation possibilities. So instead of looking at the systems that we were just selecting previously, we're now looking at the ways to relate those systems to each other. And there's various information here that will help us make a selection in the event that we actually have multiple transformations as possible ways to get from the input system to the output system.
If there's more than one transformation there in that box, how do I know what the best choice is?
Okay, so there are a few different pieces of information that we can use to help break that down if we do have multiples. First is the accuracy tag. And so accuracy is a very important consideration when selecting transformations, because this is the only step of a typical conversion or transformation process between coordinate systems where you can lose accuracy and precision of your data. The accuracy statement that you'll see in that box is listed in meters, and it is typically rated by either the EPSG or the defining survey authority that's responsible for the transformation parameters. So for this particular combination that I have, it's listing a 5-meter accuracy from input to output for this combination. And those accuracies for particular combinations that you'll see are going to vary based on the transformations. They're going to vary based on geography, and that is what gets us into the area of use as well for those transformations. So just like the coordinate systems, transformations are defined around particular geographic areas of the world. For this one example we have right here, you'll see in the map panel at the bottom of this interface, for the transformation we have selected, the only one available in this case, you'll see it's going to draw a blue polygon surrounding that area where this transformation is defined to be accurate and usable. So that information is not any kind of mathematical absolute. The area of use is simply typically published by the defining authority. So in most cases, that's going to be the EPSG database from their sort of publicly available information on these transformations. And in the event where you have multiple transformations, if you're near border areas or if there are overlapping areas, you can use these areas of use to just help make a quick sanity check that your data is exactly where you think it is. And you can also use that accuracy information to help choose the most accurate transformation. So typically you're going to want to use transformations that have the smallest number in the accuracy column. So the value that's shown there is actually the potential wiggle in your data, if you will. So in this case, my coordinate entry, we are only certain to within about 5 meters for this particular combination of transformations. And there are very, very commonly different reasons for those accuracies, but they will range from everything down to about 15 centimeters for some parts of the world and some transformations, to others that range out on order of 50 meters. Those are going to vary widely based on old technology, poor quality survey data that was the only thing historically available for certain combinations, but the accuracy and the area of use are your two best resources there for assessing which one of these to pick in the event that you actually have multiples available. As a last ditch, if you need even more information about these, you can right-click on them and view the transformation. You can actually view the parameters themselves if you actually have the full parameters for a transformation that is approved within your company or approved by your local survey authority. And the identification panel on here lets you, again, take a look at some of the other identifying information. So if I need even more information about this, if the accuracy and the area of use and the remarks are not enough, you can take some of those identifiers. Typically the EPSG is one of the best resources, and you can look that EPSG code up in the publicly available EPSG database. And there will be even more information available there, very often with information on exactly what purposes these are for and a little more technical description of some of the error parameters that are involved. So for this example, we just have one transformation available. This is a nice simple transformation. We're going to double click it and return back to our main screen. It will list off the name of that transformation in the center box, and this is the last thing we need to do before we actually go ahead and finish off the calculation. So I'm going to go down to my calculate button. I'm simply going to click calculate, and you'll notice that the coordinate entry that we have up there is going to go from red text to black text, and it's going to read out on the output side our converted value. So even though we're talking about the same point, the same location in space, relative to these two different coordinate systems, that is going to be a different numeric value for that same spot. So that is representing the shift in the datum, in this case from NAD 27 to WGS 84.
Is there a way to export or save the points once they've been converted?
Yeah, so we can either do something very simple, we can scratch this down on a piece of paper, or if you want to save a more comprehensive set of information about this data, there are a couple of methods to do that. One of which is to simply print out a one-page report with all of the parameters involved. You'll see there is a printer button up on your toolbar, and as well under the File menu there is an option to print that report out. And as well, if you want to log this out as a file, we can use the Record Interactive Conversions to simply log this out as a text file. So let's first just take a look at the print options here. When we select to print, there are a few options we can choose from, whether you want a summary report or a detailed report that actually stores all of the parameters, and then some basic print layout capabilities here as well. So I'm going to turn this on to a detailed report, and I'm going to just fill out a little subheading for our report so we can see where that goes. And we'll bring up the print preview of that. So on the one-page report that comes up from this, this can be sent straight to your printer, or you can use a print driver to send this out as, say, a PDF document. That's a very popular method for exporting these out of here. I'm just going to zoom this in a little bit bigger so we can see what's on the screen. It tells us what kind of report it is. In this case, it's an interactive conversion report, the software version that was used to generate it. Your subheading goes right at the top there if you want to give this a little bit of a title of a report for a particular location. It tells you the location of the database of coordinate parameters that you're using. So this is where you get your NAD 27 and WGS 84 for this case. And then there are essentially two halves to this page. The table at the top of the page lists all of the input and output coordinates and the names of the coordinate systems, their epoch dates, and the formatting of the numbers that we see written on the page. If we have vertical coordinate systems, you'll see those specified as well, along with outputs of things like magnetic declination and any of the vertical height scales or horizontal scales that might take place. You'll see these are all zeros on this report because we're using latitude and longitude, which don't actually have any of those convergence or horizontal scales involved. The bottom section of the report actually stores all of the parameters for the input and output coordinate system, as well as the parameters of the coordinate transformation involved. So this stores all of the complete information you need to completely replicate the transformation that you'll see with the values stored up in the top of that table. As well, if we had selected a summary report instead of a detailed report, that essentially gives you the grid at the top and skips saving all of the parameters for a little bit of a simpler layout if you're just interested in the basic names and the values of the data that we're looking at. So that's the printable report. The other method of report, again, is the Record Interactive Conversion options. And what that does is it actually saves a text log file of all of that same information that we see on the detailed report through several conversions. So you turn that logging on and then turn it off once you've completed however many conversions you wish, and that will be saved out as a text file, again with all that same information that we have in the printable detailed report level.
What if I need to convert something other than a single point? For example, what if I wanted to convert a table of points or a shapefile?
Okay, so now we're starting to get into the other jobs that we have available in the project manager. You'll see we have those four other types. So far we've been looking at the interactive conversions job. We also have point database conversions. This is where we're going to be looking to load things like tables of data Microsoft Excel files, for example, or ASCII text files. For something like a shape file or an AutoCAD file, we're going to be working on the vector data conversions job. And each of these interfaces is streamlined and has different settings to accommodate those different types of data. So what I'm going to do is open up a different workspace that's a little better example of what a workspace looks like after you've been working with the software for a while, and you start getting your custom jobs and your own unique settings stored inside it. So in the project manager now, you'll see a long list of different types of jobs, and these are all jobs that I've set up to show different types of data work that can be done within the calculator. All these jobs are simply different combinations of those same 5 base job templates that we start off with, from interactive conversions to the point database conversions and so on. If I click over to the point database conversions, you'll see here now my data is simply tabular data. So this is a Microsoft Excel sheet. You'll see the file path at the top of that. In order to actually perform a conversion on this, most of the process relating to the coordinate systems is exactly the same. We have our standard coordinate system pickers and coordinate transformation pickers on the bottom half of the interface. And really the only thing that is actually different here is now we're talking about having columns of data to convert. So on this particular interface, we have a column settings button that allows us to define which columns in our table correspond to which coordinates and coordinate systems for both input and output. In the case of the vector data conversions, it's simply a matter of listing the input file, specifying the output file and format, but then there's also some extra tools in here for handling cropping of the data, and if you have multi-layered vector data, separating out any unneeded layers from that conversion. So all of the generic settings relate to the coordinate systems and the transformations, but in all of these other special cases of different types of data, it really just comes down to the structure of that data. That's where all the rest of the complexity comes from in working with the Geographic Calculator. So to get started, I would encourage folks to work on the interactive conversions with some data that you're comfortable with. Find an example coordinate where you are confident of the input and the output value. Make sure that you are actually able to select the coordinate systems that you're looking for and validate those based on control markers and things such as that. Starting out with the interactive conversions panel on the calculator is a great way to get a feel for simply setting up all of those various pieces like the coordinate systems, getting the outputs of the things like grid scales and so on. And then once you're comfortable working on the interactive tab, it's much easier to extend on to all of those other different special features that we'll find on all those different types of data. So I'd like to thank everyone for attending the session here on getting started with Calculator. If you have any questions, please, as always, feel free to send those into our tech support team at geohelp@bluemarblegeo.com. You'll see the address right there on your screen. As well, if you have special requests for sessions you'd like to see posted along with our webcasts here and on our YouTube channel, please also feel free to send those into geohelp@bluemarblegeo.com, and we will see you next time.